Alright, so our bonus section, it's really just a review for us, simplifying radicals. Something that you should have done, should remember from Algebra 1. So let's work on that on our warm-ups a little bit. So on our warm-ups, we actually have all perfect squares, meaning our answers won't have a radical in them anymore. The square root of 121 is 11. The square root of 100 is 10. And the square root of 49x to the fourth. 7x squared. Beautiful. So remember, when we square root a exponent, we cut it in half. It's not necessarily taking the square root of 4. It was taking 4 divided by 2. Coincidentally is the same number. Questions, concerns about the warm-ups? Need more time with them? Okay. On we go. Definitions. The radical sign definition isn't so much a definition as it is just a symbol. Okay, that is what a radical sign looks like. Also called a root. In this class and in Algebra 1, I believe, unless you guys did make it more complicated, we generally just deal with square roots. When you get to Algebra 2 next year, you will deal with other types of roots, such as cube roots, fourth roots, fifth roots. Did you guys do cube roots in Algebra 1?
Yes.
Did you?
Yes.
You don't sound so
Yes.
sure. Okay, like a cube root would have a little 3 sitting in that pocket.
Oh, yeah.
Okay, you did do some of those. So you'll do more of those next year in Algebra 2. In this class, we will primarily just focus on a square root most of the time. Does anybody remember what the radicand is? Oh, somebody knew it. It's the number under the radical symbol. Very good. That's loud. The number under the radical sign is the radicand. Questions, concerns? Again, today's notes are going to go really quickly because it's a review. You should already be familiar with these things. So let's move on to our properties, which should also be a review. The product property states that if you are taking the square root of 2 terms, 2 numbers, 2 variables that are being multiplied together, that's the same as taking the square root of each of them on their own and multiplying them together. So the square root of a times b is the same as the square root of a times the square root of b. Quotient property is a similar idea. We're taking the square root of c divided by d. That's the same as taking the square root of c and dividing it by the square root of d. Of course, you could plug in any number, variable, term for a, b, c, and d that you want. Alright, a table of perfect squares. These you should ideally have memorized. In a perfect world, you would have these memorized. I know I had to have these memorized like in 8th grade when I took Algebra 1. Did you guys have to memorize these last year? No. It makes me a little sad. We played a buzz game where it was like you had a speed round, had to go around and say the next perfect square number. Good. Well, that's good. Good. All right. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. Good. If you don't have those ones memorized, I'd be a little concerned. You should at least have 2 10 squared memorized. Those are the easier ones. Up to 20 squared is ideal, but, you know. What about 11 squared? Good. 12 squared? 13 squared?
69.
Wow. Loud and proud. Good. What about 14 squared? 15 squared? Good. Oh, so we're starting to drop off a little bit. 16 squared? Good. 17 squared? Wonderful. 18 squared? 19 squared? And 20 squared you should know. That one's easy. Okay. Hearing lots of flips. Anybody need more time with that table? Going once. Twice. Moving on. All right, our examples. This first one, we are going to reduce the square root of 24 using the factor tree method and by finding perfect squares. So there are 2 different ways of simplifying radicals. In my experience, students usually prefer the factor tree method. For smaller numbers, sometimes I like using perfect squares. Let's do factor tree first. That's the one most people tend to be familiar with. We can break 24 down into what factors? 12 times 2? Okay, that works. That's not the only option, but we just need one option to get us started. 2 is prime, so it does not break down any further. 12 is not prime. What could it break into? Okay, 2 and 6, or you could use 3 and 4. Again, 2 is prime. 6 breaks into 2 and 3. Does anybody know what we're looking for after we make our factor tree? Okay, pairs of the same number. Do they need to be right next to each other? No, they just need to both exist. Are we ever going to use a number that we broke down, like 12 or 6? No. So if you need to cross off numbers as you break them down so that you don't think about using them again, do that. What do we have a pair of? 2. So we've got a pair of 2s. What's alone? A 2 and a 3 are both alone. Anything that had a pair, one of those numbers goes outside the radical. So we can bring out 1, 2. Anything that didn't have a pair stays underneath the radical, and they would get multiplied back together. So what would we have? A 6. Is this all coming back to us from Algebra 1? Okay. The perfect square way, I won't necessarily show on every single type of problem, but it uses the product property. So I know that 24 can be divided by 4, which is a perfect square number. So the square root of 24 is the same as the square root of 4 times the square root of 6. We all understand why I chose 4 and 6? Okay, and of course the square root of 4 is 2. So 2 different ways, you get the same answer. So it does not matter to me which method you prefer as long as you're showing me your work. Okay, so these were the 2 different methods. Questions? Need more time? Concerns? Moving on. All right, I'll give you a minute to at least do examples 2 and 3 before we talk about them. If you are comfortable with this and you go ahead and keep working, that's fine. Examples 4 and 5 we haven't quite talked about in detail yet. Well, 4 we kind of did. 5 maybe not so much. Did anybody get an answer for number 2? Ari, what'd you get? 6 square root what? I think you're almost right. Paris, what'd you get? 6 root 2, I would agree with. Again, you could do it the factor tree way, only because it's quicker to write. I'm just going to do the square root way, the perfect square way. So 72 is the same as 36 times 2. The square root of 36 is 6. Oh, okay. Questions about example 2? Again, if you showed a factor tree instead, that's fine. Anybody get an answer on number 3? Akira? What square root 3? I almost agree. Caleb, what'd you get? 4 square root 3 sounds better to me. We could break this into the square root of 16 times the square root of 3, which would be 4 root 3. If you did a factor tree, I think a lot of people probably would have gone for 4 and 12 or 2 and 24. But you would end up with 2 pairs of 2. So remember, for each pair, one of them comes outside. So if we have 2 2s, 2 times 2 is 4. Questions about example 2 or 3? Okay. Did anybody go ahead and get an answer for number 4? John? 4. I would agree. We multiply these together, and we would get the square root of 16. The square root of 16 is just 4. Remember, if you have a perfect square number under the radical, and that's all there is, then there is not a radical left. It just, poof, goes away. All right, number 5 we didn't talk about yet. Did anybody get an answer, though? Brianna? 8 root 6 sounds good. So you might remember from Algebra 1 that the numbers on the outside get multiplied together and stay outside. The numbers inside get multiplied together and stay inside. We should check to see if we can simplify it, but of course 6 does not give us any pairs when we factor. So 8 root 6 is our final answer. Any questions on 2 through 5? Anybody need more time? On we go. All right, these ones we will simplify using the quotient property, meaning you can take the square root of the top or numerator separate from the denominator. Sydney? Good. So on this one, I don't expect that you would write this out split up, but here's what I mean. You can square root them individually, which, yes, would give us 1 over 3 or 1/3. Any newbies want number 7? Ataya? Good. Square root of 36 is 6. Square root of 25 is 5. Number 8. Seeing a lot of repeat hands. Akira? 10 over 9. I agree. Square root of 100. Square root of 81. And what about number 8, Kobe? 8 over what? 8 over 2, which simplifies to be a 4. Questions, concerns before the fun part? Nothing? Need more time? Moving on. All right, rationalizing the denominator. When we are working with the quotient property, we cannot leave a radical sign in the denominator. Not allowed. So we have to rationalize it. Does anybody remember the process for rationalizing? Ataya?
Multiply the numerator and the denominator by the radical.
Very good. We multiply both the numerator and the denominator by the radical that we're trying to get out of the denominator. So in this case, that would be the square root of 3. We multiply straight across the top, straight across the bottom. 2 times radical 3 is 2 radical 3. Nothing fancy happens there. What is the square root of 3 times the square root of 3? Okay, it's the square root of 9, so if you need to write that to see it, that's fine, but we know the square root of 9 is really just 3. The last thing you should do is check to see if anything can simplify. Can we simplify these 3's? Why not? Okay, one is under a radical, one is not, so do not try to simplify those. 2 over 3, of course, does not simplify, so this is what we're left with. Questions on example 10. All right, it's not totally essential, but I prefer to rewrite my radical broken up over my numerator and denominator before I begin. It's kind of just personal preference. In this case, to rationalize, I should multiply by over. Okay. Same radical on top and bottom, so that way we're really just multiplying by 1, which we know doesn't change a number. We're not trying to change the number, we're just trying to rewrite it a different way. Root 6 times root 5 is the square root of 30. Square root of 5 times square root of 5 is root 25, which is just 5. Okay, again, if you need to write that part, you can, but hopefully you'll start picking up on the fact that multiplying a radical by itself just gets rid of that radical symbol. Can we simplify the square root of 30? No. If we were to try to, like you make your factor tree, we would have 3 and 10, for example, 2 and 5. We don't get any pairs. So it does not simplify. We leave it there. If it did simplify, I would expect for you to simplify it. Questions, concerns, need more time on 10 and 11? Okay. Go ahead and try 12 and 13 on your own. These ones, there are a few more steps to simplifying after we rationalize. So make sure you're fully simplified. You can go ahead and rationalize first, though. Anybody get an answer for 12? We're not sure. Brianna, what'd you get? 3 root 26 over 13. Anybody else get that one? Okay. So, to show some work for that, just in case you hadn't quite gotten there or simplified it fully, to rationalize, we multiply top and bottom by radical 13. The square root of 18 will simplify on its own. So the square root of 18 would give us square root of 9 times square root of 2. I'm just going to write that down here as a little note. That gives me root 9 times root 2, which I know root 9 is just 3. The 2 that's under there is going to get multiplied to the 13. That's how we ended up with the 26. And of course, in the denominator, our radical just cancels out, so to speak. So I would agree with 3 root 26 over 13. Which part?
The part about the 26.
So if I were to simplify the square root of 18, I would end up with 3 root 2. And then I'm multiplying that to the square root of 13 from the top here. Does that make sense? Okay. If you wanted to, you could multiply 18 times 13 and you'd get some larger number, but then you'd still have to break it down. So I would try to simplify a little bit as you go. Or sometimes I just leave it as 18 times 13 and then I can see the smaller numbers and you could factor tree them then. Of course, 13, you wouldn't make a factor tree because it's prime. 9 and 2, 3 and 3. Either way, doesn't matter to me how you get to your answer as long as you show me what you did. Other questions on 12? Answer for 13. Caleb, what'd you get?
8 square root 2 over 2.
I would initially agree with that. So that would be a good first step if we multiplied top and bottom by root 2, 8 root 2 over 2. But what could still simplify? The 8 and the 2. 8 divided by 2 is 4. So our final simplified answer should be 4 root 2. Always double check it at the end and make sure it's fully simplified. Any questions, concerns?